today's topic is blockchain ready for AdTech? So with that question, I thought of asking more questions because it's complicated. And you look at it, the first question is it blockchain or blockchain? Right? So, and I looked at the paper that's originally written by this unidentified billionaire, I guess, somebody who can just wake up and write a paper and just create something and make billions of dollars. That's only possible at this time, only using technology. But there is no word named blockchain in that paper. And there is a word block, there is a word chain, but there's no blockchain. So we don't need to worry about whether it's blockchain or blockchain. Whatever you feel right, you can use it. Is it a hyper real? It's neither. I remember my days in Java back in like 25 years ago. When people use the word Java, there's like 20 people surrounded. Something is going on, and the conferences fill up. And there were no internet. This is like a magazines. I got to go buy them, and they draw this picture that I couldn't understand, but they write all things about Java. I tried to learn like a fourth line or fifth line, I would fall asleep. And they talk about Java ring. You wear this Java ring. You can go near to the refrigerator. You can open the refrigerator. I'm like, why do you need to wear a ring to open a refrigerator? And I was building Java applets. How many of you build Java applets here? Right? Applets is going to change the world. And I write all these event listeners, like 20 lines of code to click a mouse button that's going to just minimize the window. My colleague sit next to me and he write like a 3-word code in Visual Basic. I was still challenging him, Java is going to change the world. And it is, but the point is, it's not about the hype that created by the industry or the magazines or whatever. Underlying technology matters. That's what we're going to talk about today. And who is Satoshi? I want to see him at some point, but wish him luck. Should I invest in Bitcoin? I have no idea. That's up to you. Is blockchain Web 3.0? I'm interested about that because the next wave of building distributed applications, should we leverage blockchain or not? That's a serious question engineers should be asking about it. And where do I start? So I prepared this talk originally for a 45 minutes deep dive tech talk, then starting to look at the audience because we wanted to make sure this is not about us showing off what we do or what we build. It's about learning and teaching. So we looked at the audience, and there is a diverse group. We have people from sales, we have people from product, we have people from engineering. So it's an important topic. Everybody wants to know what's going on. So we kind of adjusted the timing and slides. So we have more people, and we have our partners, as well as my team to talk about overall what is blockchain and where is blockchain, and is it ready for AdTech. What I wanted to do in the next few slides is you to walk out with one thing. If people come and talk to you about blockchain, you don't have this vague, some kind of a guilty feeling that everybody knows about blockchain, but I'm the only one who don't know about blockchain. That's the thing I wanted to clear it out. Let's do it. How does blockchain operate? So think of like creating transactions. One or more transactions get created, and the network of nodes. These nodes are bunch of computers, P2P, peer-to-peer computing network, sitting there, ready to process the transactions. And the transactions need to be validated because anybody can create the transactions. And the validation is proof of work or mining. I'm going to use a lot of these terms. I apologize if you don't know, but make a note of it. You can look it up. There are different examples on the net, so you can just learn it. But I need to finish it quickly. That's why I'm just going to rush this through. So validation, those transactions get validated. Then the verified transactions are added to the block. That's where the block is, and the block added to the blockchain. So a bunch of transactions in a block, and bunch of blocks is a blockchain. That's the concept. It's very simple. And these blocks, if you look at it, that's the header of the block. Each block has a reference to the next block using this hash. And the data structure underneath is like multiple transactions, uses hashes of hashes, using like a Merkle tree data structure to build these blocks. So that's a very simple way of saying like what is blockchain and how does it operate. Bunch of transactions get created over the network of nodes, validated and added to the blocks. So what is a blockchain platform or a protocol? Remember I said, like, if somebody tells you blockchain, I want you to know at least what they're talking about. So these are the terms when somebody tells you, they're talking about the blockchain platform. So again, what is a platform? It's somebody can build on top of it. Right, so any applications can build on top of it. Like you see Bitcoin here. I'm not talking about the cryptocurrency or somebody who makes millions of dollars overnight. I'm talking about the Bitcoin as a platform that transactions run through that. So these are the popular blockchain. See, I'm got confused between Bitcoin and blockchain, right? That's what this does. So blockchain platforms, these are the popular blockchain platforms. So I picked two of them just to show what are the things you should look at it to differentiate, to understand. Whether it's a distributed or not, I mean, blockchains are distributed, it's public or not, both are public blockchains. And as I said, data structure, all blockchains use Merkle tree data structure because of efficiency and validation, and it's hashes of hashes, so it uses the data structure. It applies blockchain technology, no doubt. But the Ethereum uses for running those transactions is like a smart contract. So people write this code, it's called smart contracts. It runs through that decentralized platform. Whereas Bitcoin, it's a platform that people uses for electronic caching system. So it's really a blockchain platform. People use it to cache their transactions. But the miners, remember I mentioned about validations, people who verified validations, they collect ethers when they use Ethereum platform, when Bitcoin miners earn the Bitcoin. So that is a whole separate topic about what mining is. If you don't know, just can search for what is Bitcoin mining. A lot of people buy powerful hardware and solve these complicated puzzles and rush to validate those blocks when they get added. So that's called mining. So they earn these Ethereum as well as ethers. So that's picking two different popular Bitcoin platforms to compare side by side. But this is an important slide I want you to explain. At a very high level, there are three types of blockchains: private, public, and consortium. So if you look at public, anybody can create a transaction, anybody can validate, and anyone can verify. Right? It's a very open platform. And the volume is high because people put a lot of transactions. The speed is low, obviously. There's no doubt about that. So the examples are Bitcoin, Litecoin, and Ethereum. If you look at private blockchain, it's the opposite. It's permission-based. Any company can create their own blockchain platform and allow only specific users to create transactions. It's permission-based. Volume is low, obviously. The speed is faster. Is it trusted? Depends on who you allow. Obviously, it's permission-based. Private means I would allow only people who are allowed in my network. The consortium is an interesting thing. Multiple companies, group of companies or group of people can create a blockchain across them to access. So it's also permission-based. Trusting and volume and speed, it all depends on who they allow. So people talk to you about blockchain, you should think about whether it's private or public or consortium-based. I gave these examples. So this is a platform. So now, all these applications that you're hearing and seeing is built one of these platforms. So you can go to Azure and create your own private blockchain platform and set up a couple of nodes, create transactions, and validate against them. It takes like an hour. If you're really interested, you should absolutely try that. So how can you learn? As I said, my goal for this 10-minute talk is to explain you at a very high level, to clear the mystery about what is blockchain at a very high level. So what are the things that you can learn from here? Definitely read some papers. There is a link there. And try to understand some basic algorithms and data structures. What is hashing means, what is one-way hashing means, how do they validate and translate, and what is the Merkle tree data structure. It will help you. And if you're really not trying to understand the under the hood of blockchain, it's still okay to understand some of the concepts, how public and private keys work, and what is consensus means, what is mining means. But most importantly, if you wanted to build an app, go create your own private blockchain network, either using multi-chain or Azure. You could just go there. There is a template you can download and create a server. You can set up 2 nodes and run an entire blockchain network on your computer or on Azure. So you can tell your friends, hey, I run my own blockchain. They probably think that you're a millionaire again. But so then learn about smart contract and deploy. So you can use the languages like Solidity. It's like a very simple JavaScript language. You can deploy using a framework called Truffle or whatnot. So I'm just wanted to give you the hints like what are the things instead of like going and zooming like so many things. These are things you can easily pick it up. But so let's say you don't want to build a new app or build a new network. You still can use some of those apps, extend their APIs or extend their SDKs, so you can still be part of some of the blockchain application. So in your head, I want you to think like 3 levels. One is the blockchain platform. The second one is you creating your own blockchain network. Then the third one is you are creating your own app, like a distributed app. The fourth one is, I don't want to do any of those. I just wanted to use an app. You still can use their APIs and build an app. So that's what blockchain is. It's very simple. But anything that I didn't say about cryptocurrency or ICO, I don't know anything about it. Just ignore them. So the questions you should be asking, is it a blockchain when you're talking about a platform or an application? Is it a private or a public or a consortium? What am I getting into? If I'm sending the transactions, who is seeing and who is verifying? What business problem you're trying to solve? That's the first thing we ask. What use cases you're really trying to solve? But everything else, look at all the ICOs that generating millions and millions of dollars. Developers can create a currency, and I see people like doing all sorts of coins, like banana coins and kitties, whatever you want. But that's not what this talk about. But that's a distraction for an engineer and a product leaders if you want to think about how blockchain as a technology want to solve business problems. So with that, let's get into business. So we're going to cover 3 things. I'm going to assume nobody knows about AdTech, which is true actually. Everybody thinks they all know. So Mike is going to come and demystify some of those things. What is the complexity under the hood of AdTech? Then privacy and trust and transparency is the 2 of the use cases. Remember I said what use cases or business problem we're trying to solve. Those 2 use cases we're going to pick. And our partners and my colleagues, Anjali and Mike, are here to walk you through. This is going to be a fun conversation.
All right, I'm Mike. I'm a software engineer at AppNexus. I unfortunately don't get to send out my slides and be like, hey, make them look good. Ben just emailed someone this morning, instantly slides look good. I emailed someone last week and no one responds to me. But one day I think I'll have a title good enough such that I can have my slides look good. But for now, these are just whatever I made. So I'm going to go over some AdTech problems, and I'm going to start by introducing sort of who the different players are within AdTech. So this is our cast of characters. First of all, you have some computer. Maybe it's a tablet, maybe it's your iPhone, or it could be a connected TV. Whatever it is that's going to ultimately try to get an ad to show to a user. Publishers are the ones who actually have the content. Maybe it's Watch ESPN, who's streaming live sporting events, or it's CNN with great journalism. So you have your publisher, and they want to make some money. And so then there's the advertisers who are saying, well, yeah, I'm willing to spend some money to put some ads on top of whatever content you're putting out there. And then you have all these intermediaries. You've got all these people in the middle who are going to try to actually connect all the dots. So when all these dots try to connect them all, there's a ton of problems. So there's no transparency. There's a ton of discrepancy. All the numbers at the end of the month don't ever add up, and no one really knows how much they owe anybody. There's a ton of fraud, and there's no real idea. Users' privacy is sometimes hard to know what's going on. I'm not going to talk about the bottom 2, but I am going to talk about transparency and discrepancy. So first of all, what do I mean by transparency? I mean that at the end of the month, a DSP goes to the advertiser, and they're like, hey, you owe me $1 million for all the ads that you bought through my platform. Then the SSP, also the SSP stands for Supply Side Platform. DSP is Demand Side Platform. There's a ton of lingo in AdTech. That's also confusing. So they say, hey, I'm going to give you $600,000 for all the ads that I helped place on your site. And then these 2 call each other, and then they talk. And the advertiser's like, hey, I spent $1 million. How much did you make? Publisher's like, I made $600,000. And the advertiser gets really mad. Advertiser's like, what happened to 40% of my dollar? And there's expletives because he's really mad. And then so what happened, right? So maybe something like this happened. He put in $1 million. The DSP took some percent. The exchange takes some percent. And then the SSP takes some percent. The percentages don't add up to 40, but when you multiply them, it would be 40. You can do the math at home. And so So why can't we have this kind of UI? Like, it'd be awesome if an advertiser could like log in somewhere and see like, oh, I see why 40% of my dollar like got evaporated into these intermediaries. Like, let me clean up the supply chain. But like, there is no UI that could ever show that, and why not? Ultimately, companies are very afraid to disclose their fees. So for example, let's say the DSP tells the advertiser like, hey, yeah, like I'll only take 10%. Then there's like these fine print fees, like, oh, I'm going to take 5% for this or 5% for this thing. And they're maybe in the contract, so they're not necessarily sketchy, but we don't necessarily, like, all these intermediaries are afraid to bring these sort of fine print fees to the light. Also, when all the fees become public knowledge, there's like a fear of margin compression. All these companies are trying to stay alive. As like all the take rates go down, companies will have a harder time staying alive. So companies generally don't want to disclose their fees. Also, the legal contracts that these intermediaries have with the clients don't have any transparency in mind. Usually it's like, and we will never disclose your rate to anybody else. But other people are like, wait, but I want to know the rate, what you're taking. And so now all of a sudden it's really hard because all these contracts need to get updated. And really there's no like place where all this data lives. Like every single company kind of just running their own database, and there's no one-stop shop that actually has all the data. So can blockchain help? Kinda. Like, you can't just magically force companies to be transparent. Those are like legal conversations that no technology is going to help. Similarly, blockchain can't go update client contracts. Like, lawyers need to talk. But blockchain could help push the industry in the right direction by encouraging people to have the right conversations. And potentially, there could be a company that's trying to sort of get all the data from all these intermediaries, and that company could use blockchain as sort of an underlying technology to store that data in a trusted way. So blockchain could help sort of aggregate this data, and someone's going to come up later, talk about how they're doing that, but it doesn't automatically solve a lot of the problems within transparency. So that's transparency. Next is discrepancy. So what do I mean by discrepancy? I mean, in my previous like transparency stuff, all the numbers tied out. So like imagine that the SSP, this is like their database, they're sort of keeping track of their accounts payables and receivables, right? They think, okay, I'm going to charge the exchange $750,000, and like it would be awesome if the exchange totally agreed, right? At the end of the month, the exchange is like, yes, I think that's how much I owe you. And similarly between the exchange and DSP. In reality, that's like not even close. Every single month, the numbers are vastly different, and this is just an accepted reality within our industry. What might happen is like the SSP will send an invoice to the exchange and be like, please give me $875,000, and the exchange is like, whoa, I didn't think I owed that much. I only thought I owed like $820. Similarly, the exchange will like invoice the DSP, be like, please give me all this money, and the DSP is like, crap, I didn't think I owed like an extra 70K. And this is like very, very legitimate. Like I've seen the numbers, I don't know if I can expose all that, but it's like, it's off very regularly by a lot. And so the current state of affairs is that like up to 10% is common. Like at the end of the month, these numbers are like vastly off, and like depending on how big you are, that will determine like how much actual power you have in this. Like more or less, you're a big company, you can bully small companies. Small company sends an invoice, say like, you owe me $1 million. Big company is like, screw that, I'll just pay you whatever I want to pay you. And so there's no real way to actually like fix this right now. And so can blockchain help that? Well, I'll get to that in a second. First, I want to explain why does discrepancy exist. So I'm going to sort of go through sort of the life of an ad call, and I want you guys to be thinking like, where could potentially some data get written to a blockchain that could potentially help solve discrepancy? So what happens is a user goes on their phone, and then they're on some whatever blog post, and an ad call gets made. And so the ad call goes from the phone or the laptop to the SSP. The SSP makes the request to the exchange, and then the exchange will forward that request to the DSP. And so now the DSP has to pick a line item or a campaign that an advertiser has pre-set up to select in order to bid on that domain or that user. So let's say the advertiser submits a bid of $100, and they'll submit their like actual image. Like that purple blob is like the actual JPEG, or maybe like the actual video that they're trying to put on. The DSP will take their cut, and they'll wrap it. So sort of like think like they're building an onion. Like the DSP will sort of wrap it with something that will help them know, did I actually win? The exchange will do the exact same thing, and then the SSP will do the same thing. So you end up with this like really big onion. And let me just go into a little more like, what is that onion? More or less, the outside is like the SSP's thing, and the SSP says like, yeah, I'm going to pay $60. And really what this is for is so the SSP knows the ad rendered. Then those question marks basically are the exchange saying like, hey, SSP, you might be doing price reduction or second pricing or like various auction dynamics, and I don't really care what you do, just like tell me how much I owe. And so therefore, like there's this macro. So the exchange will say like, hey, please fill in this price paid macro so I know how much I owe when you tell me I win, should I win? And then the DSP does the same thing. There's like this macro, and it's like the exchange is supposed to fill in this DSP price paid macro. So let's figure out like what actually happens on this notification path. So you just like basically all that stuff happened, and now like everyone's done, right? Like all the connections are done, and like all those requests and responses are sort of like maybe they're like all of it's sort of gone. Everyone maybe like probably what they did is they wrote to their database saying like this auction happened. I don't know if I transacted. I have no idea how much I really am going to pay the seller, and I don't know how much I'm going to charge the buyer. And there's this big fat onion sitting on someone's browser. So you have all these databases with like just like really like pending auctions and a big onion sitting on a browser. And then like the first request will get sent to the SSP. It took a long time to do animations, but I'm pretty proud of them. And so the browser will send it to the SSP. The SSP will peel off their layer of the onion. Right? They peeled off their layer. Then they'll update their database. They'll say, yes, this transaction happened. I owe the seller $60. I'm going to charge the buyer $67. And they'll fill in that macro, price paid $67. And it's very possible the user will just leave the page now, right? And so the SSP thinks this auction transacted. And then the exchange and DSP are sort of left in the dark, right? Like if the user leaves the page right now, exchange thinks, oh, I guess I lost. DSP thinks they lost. But the SSP thinks it's super legit. So if the user didn't leave the page, then what will happen is the SSP will send that back to the page. The browser will then send it to the exchange, and the same thing. They'll unpeel their onion, update their database. Now the exchange and the SSP are aligned. The DSP is still left in the dust. Hopefully the user stays on the page in order for this final request to get made to the DSP. They'll update their database, and finally the ad made it to like the user's phone. And like ideally now everyone's in sync. But this rarely happens. So what are the issues? We're like fully relying on the browser for these notifications. If the user leaves at any time, most likely someone later on the chain will not know what happened. There's a ton of duplication. Like who knows what the browser's going to do? The browser might hit you multiple times, so every single one of these companies has to have very strong deduplication logic. Also, there's no established best practices. In that example that I showed, everything was very in series, right? It was like the browser sent to the SSP, back to the browser, then to the exchange, back to the browser. In reality, sometimes it's in series, sometimes it's in parallel, and sometimes there's like client-side notifications and server-side notifications, and sort of anyone can pick what rules they want to do. So say you're getting a client-side and a server-side notification, you could decide, I always require both, or I only require one, or I'll require both, and if I get both, I'll just pick whichever one I make more money on. Like there's no real best practices, and everyone kind of does their own thing for how they manage receiving these notifications. And there's a ton of processing errors. There's a ton of volume within AdTech, and I'm sure these companies do not have like not all of them can have like fully robust, fault-tolerant stream or batch processing. So can blockchain help? They can definitely help because they can provide that single source of truth. Like ultimately now, instead of having all these different databases that like hopefully end up magically being in line, if there's just one single source of truth that's deciding which parties transacted, did this auction happen? But just having everyone like write to a blockchain will not like, it's not super simple because there's a ton of volume. And so AppNexus alone, like there's 4.5 million potential transactions a second. So like the amount of times where we could potentially win an auction is insane. And like this naturally would not be supported by like blindly putting a smart contract on the public Ethereum network, which can probably support like 20 transactions a second. Like 4.5 much greater than 20. And so that's not simple. So you need to probably do some like maybe private chain and public chain thing. Another thing is the amount of completed transactions is much less. So maybe we could try to figure out some way where you don't necessarily have to listen to all the potential transactions and people actually only write the completed transactions. So really crappy inventory isn't bogging down the blockchain that's trying to keep track of all this. The last thing that makes this really difficult is the whole idea of there's no real standardized set of rules. Like it's not going to be simple to make a smart contract that keeps track of everything. Like someone requires views, someone requires this verification vendor in order to transact. And so everyone has all these different things, and having a smart contract that can actually keep track of everything and be generic is not going to be simple, and it will require a lot of people in the industry to work together to figure out like how can we actually build something that is robust and can really clean up this industry. So that's discrepancy. Blockchain can kind of help these things. It will require a lot of thought. And up next is Daniel from Amino, who has someone in design because he's VP engineering, so he gets people to make his slides look good.
Hey, what's up? I'm Daniel, VP of engineering at Amino. We are a payments company, and we are using transparency to solve a lot of the problems that Mike was just talking about. We want to reduce fraud, waste, and abuse in the supply chain. A lot of our ideas and technologies are inspired by blockchain, but we've still had to make concessions as to where we could use it and where we cannot. Let's start with the big problem. I like talking to Mike Freyberger. So basically, the big thing is volume, right? If all of us were to write every transaction we were involved with onto the blockchain, we would end up melting something, right? So I'm picking on Mike here, and that's because he already presented and can't defend himself. But I feel like Mike's up for just about anything. Yeah, moving on. So what did we do to solve this problem? We split our stack. We have a high volume off-chain stack. We use a centralized ledger. It's ready for AdTech scale. It's modular, so as things improve and blockchain progresses, we can move more and more items over to blockchain. It may not be as cool as blockchain, but what we do is actually really quite cool. Separately, we're working with Hyperledger. This will allow us to connect with our customers on data. It also aids us in reconciliation, which allows us to reconcile quickly and then settle payments quicker. So first, nice animation, right? First, we're going to talk about our high volume stack. So what you'll find here is stuff you're probably used to if you work in a high volume environment. We do streaming, batching, app servers, that sort of thing. But you'll also find kind of a primordial mix of blockchain components mixed in. You can see here that we handle several types of calls. The first one, and most obvious, is pay. So those are actual payments. We provide an SDK to our customers to sign those transactions, and then they send them in to us. We also serve a pixel along with every advertisement being paid for, and we receive some information from verification providers. All of these come in through plain vanilla HTTPS in our app servers. The app servers have one purpose, and that is to serialize the data they're receiving and get it into our stream and batch stack. What this stack here, you could kind of think of this as a Merkle tree factory. We heard a little bit about those before. And what's going on, you can see these structures being built. We'll talk about them in a minute. Those are amino chains. And as stuff exits the stream batch stack, it goes into our centralized ledger. So let's take a look at what an amino chain is. Amino chains is basically a data structure we've created. And as you can see here, it gives great visibility into what is happening with an ad buy. This chain here represents just a single impression. You can see money flowing from the brand into the publisher. We operate on a currency called grains. It's tied to US currency. 1 grain is 1 nanocent. And you may ask, why would someone tell the truth here if they wanted to hide how much they were keeping, right? We execute the payments, so we can enforce this data. If they misreport what they're paying to the next person in line, we're actually going to give that money to the next person in line. One cool thing about these chains is if you stack a bunch of them together, you end up with a graph. So this graph structure is really great. It provides an excellent overview into where any single party in the chain is spending their money or receiving their money. This is from the perspective of a brand. We have a UI connected to our centralized ledger, which in near real time can produce this kind of data for our customers. So we get a bunch of chains in our Amino ledger, which is centralized. And then in order to get them into a blockchain in a reasonable manner, we aggregate them up into 1-hour chunks, and we stick them up into IBM's cloud, where we host our Hyperledger. Let's take a more ledger-centric view, or Hyperledger-centric view of our stack. If you look here, you can see Event data is flowing from, these are some customers we're working with. Event data is flowing into our fast processing stack here, and then into the Amino ledger, just like the previous slide. From there, you can also see all of these customers are connecting on another shared ledger. This allows them to either privately or publicly share smart contracts. So we think of these as generally terms that they're agreeable to when doing ad buys or sales. So as the data moves from our Amino ledger into the centralized ledgers, or sorry, the distributed ledgers, we can execute contracts. These contracts, you can see here, we're receiving data from the data vendors like IAS and White Ops. They're providing some metrics on the performance of the advertising. So these contracts were shared in advance, and if these hourly blocks that we're creating are executable, we'll, at this point, then check out the smart contract, make sure all the terms were met, and execute them, inserting into our channel-based ledgers. These channel-based ledgers are generally shared just between us and one other party, and that data contains all the chains that they were involved with. Let's take a look at why we like Hyperledger. Well, for one, we like being involved in an OSS community. It's backed by the Linux Foundation. We love being contributors and receivers of support from the OSS community. Their offerings are business-focused, which our customers are generally concerned with privacy and don't want their competitors to see how they're buying and selling ads. They offer Composer, which is a very straightforward way to produce tools to interact with the ledger, and that doesn't just benefit us, but also any customers. And IBM Cloud, in the same way, provides an easy way to spin up nodes, which allows us to scale our ledger and easily allow customers to join our network. But I don't want to talk too much about what IBM is doing, because next we have Eileen Lowry.
My name is Eileen Lowry. I lead our blockchain garage for the world, which is a fun task. I get to help clients solve their business network problems day in and day out, and also build blockchain applications with my team of architects and developers based here in New York. What is IBM doing around blockchain? And I want to really emphasize the fact that this is really a broad opportunity across a lot of the industries where actually at the end of the day, a lot of these networks come together. And IBM is really focused on bringing enterprises, startups, developers come together to help them start their journey, accelerate their journey, and really extend their journey when it comes to blockchain. You've heard a lot of the speakers before me talk about different participants, a lot of different players in these streams of information, and that's true. And there's the concept of a network is really important, and so bringing together those ecosystems is an area in which IBM is highly focused. But as I said, we're focused on really helping all types of clients on their journey, and at the same time, we're highly focused at the bottom of the stack and contributing to the open source, Hyperledger specifically, and seeing that advance such that we can build on top of that, take advantage of the open source, the openly governed components of Hyperledger, and build on top of that and differentiate using our IBM Cloud, in which we have our platform to help it make it that much easier for developers, enterprises, startups to deploy their blockchain applications. On top of that, we are highly focused on building and solving business problems for clients. And so we've built several solutions. You may have heard about our work in IBM in the food trust and safety area with our solution, IBM Food Trust. We've also really been highly focused in the supply chain space. You heard before from Mike around showing just the sheer number of players that are involved in showing an ad. And when you think about that in the grand scale of many different industries, shipping a good from one place to the other, actually moving a good, all of that entails a supply chain. And so our joint venture with Maersk around global trade is an important area for us. All of this gets wrapped around the concept of ecosystem and services. The fact that you're having to interact with other players and needing to think about who are all those other players, and at the same time helping clients to really build that solution, figure out what is the business value, and derive that business solution with you. We're here to talk about AdTech, but AdTech and any industry actually intersects. We heard about payments. Payments from a financial institution, what actually had to happen to settle that ad? You had to exchange money. And so where a lot of this has derived from is the financial services, except for blockchain is applicable to many other industries. There's a lot of skeptics out there as far as, is blockchain for everything? And you heard some of the, the comments early when we started off with Ben of, there's a lot of hype. Is it real? It's real, right? I will stand in that camp and say it's real because we've worked with over 400 clients to make blockchain real for their businesses. And it does actually span a spectrum of industries. Does it mean it's applicable to everything and anything from a business problem standpoint? No, you do need to look at, what is it that we're trying to solve, and is blockchain applicable? Are we digitizing processes with friction amongst players? Are we having to help from a non-linear perspective bring together new players? Or can we actually think about a new business model itself? But I wanted to show this off just that you can get the wheels turning and thinking of, yes, we're here about advertising, but how does advertising tie into other industries such that when this becomes even further in the life cycle of blockchain into networks connecting with one another, that you can start to think about how some of these networks might connect with one another given the use cases and the business problems that we're looking to solve. We started off the talk tonight talking about different aspects of blockchain. You heard a fair amount about public blockchains and different protocols. IBM is focused on private permissioned blockchains. And from that vantage point and working with our clients, there's 4 main tenets to a blockchain for business to really instill that trust within a network. The most obvious piece of that is the shared ledger, that shared replicated information across the different participants in the network. Smart contracts, you've heard this term quite a lot. At the end of the day, this is that business logic that needs to be validated and therefore executed to conduct a transaction and add that transaction to the blockchain. I'm going to talk about privacy in a little bit more depth, but at the end of the day, when you are transacting in a network focused on business interactions, you need to have that appropriate visibility across the players. You heard from Dan talking about how he has different clients, sharing different information with them, but they might not have that same visibility across all of those different participants in the network because of the things that you heard from Mike around different rates and fees and so forth. And of course, proof. You heard some of the terms around proof of work and mining. In a blockchain for business, you don't necessarily need that. You don't need that compute power of computers running in a dark back office trying to mine for information. There's means in which you can actually get the relevant participants to agree and endorse a transaction, such that now you just have a matter of ordering and how did those transactions occur and when did they occur in what order. So I'm going to go from this very high-level view, and because we have a very mixed audience, I get the pleasure of showing an architecture chart and one chart right after this. So get ready to go much deeper. In the matter of like 2 minutes, we're going to go really deep into architecture. So privacy, which is what you saw, I circled on the last chart, is really about providing that privacy and confidentiality between the subset of participants. When you're talking about Bitcoin and being in an anonymous network where everybody can see everything, that's great for the purpose of what that network might be for. But when you're talking about businesses that may have strategies that they need to protect or that they want to protect, but there is information that is crucial for them to share in order to move goods faster, to actually break down the barriers of what an ad actually costs and was it placed, that having that right privacy and confidentiality is very important. Blockchain is actually taking advantage of many other technologies to do that. So in our case, cryptography is essential, and it's central to the process of actually executing that transaction and ensuring that the right people have the ability to see and execute upon that. So bearing that in mind, the really geeky chart here from a Hyperledger perspective, this is the overarching architecture for Hyperledger. And what I want to focus on is just the privacy piece of that and where it's relevant for some of the examples that you heard from today already. Imagine on this side of the chart, right? This is a front-end application. Maybe you are trying to check how your campaign from an ad perspective is doing, and you've got an interface then to the blockchain itself. These O's here is called an ordering service. When you execute a transaction, you heard from Ben earlier, there's this validation that happens. The validation is happening between different entities on this side of the chart, but really at the end, after something is actually validated, you want to order those transactions. How did they occur? Did they occur 1, 3, 2 or 1, 2, 3? So that's what this piece of the architecture chart is really trying to demonstrate. And what happens is then you've got a bunch of different entities, we'll call them here endorsing peers, that have a copy of that shared ledger, and they are executing and validating those transactions that need to occur and then get pushed into the ordering service itself, such that then that's going to order those transactions. You have something else here called a committer peer. A committer has a copy of that ledger as well, so they understand what's going on. They've got information as it's shared across the different shared ledgers here, but they don't necessarily have the ability to actually validate anything. So they can consume information, but they're not writing and executing on those transactions themselves. On a couple charts ago, I talked about smart contracts. In Hyperledger Fabric, the term is called chain code, really just, again, that business logic that's going to get executed by those endorsing peers, and in which all of that information is ordered and then shared across all of the different types of nodes, endorsers, and committers. So what does this all mean when it comes to privacy? Take a very simple network example. You could imagine that this is one brand, and this is one agent publisher. So you have maybe another network organization here that might be the actual agency itself. So we've got different organizations. They're all transacting with one another. How do they know? How do they keep things private if you've got two brands? Say you've got Nike and Adidas, and they don't necessarily need to know, again, the rates that were used or the fees that are being executed on, taken from the various elements of that chain. So they might have what's called channels, two different channels with that same agency and publisher throughout that chain. So what actually would end up happening is they have private information that gets shared between these different channels. Think of them like radio stations. You're tuned in and you're allowed to listen. So in this case, Y and Z, you can see the smart contracts are visible and executable by these two entities that are talking to one another. And at the same point in time, you've got this entity and that entity that are able to actually transact with one another and communicate, but they can't see and execute on the other information. So again, Nike might be conducting, placing its ads, and you've got an agency on their behalf working with a publisher, and they're able to transact on that information, but they don't see the rates and the fees that maybe Adidas has. So they're still allowed to have those trade secrets, the competitive nature with those different agencies. You can imagine how this expands out into many other brands, and you saw it even on Dan's chart of he had the different verticals of where you have that privacy. But very important piece of transacting from a blockchain standpoint, because we know that you have trade secrets, you have strategies that give you that competitive advantage, and channels is the means by which you can actually provide that privacy and have those sub-ledgers of information that gets shared across the different participants in a network. So we went from really high level to understanding a little bit about privacy to really deep into Hyperledger architecture and the means by which we take advantage of privacy. And now I want to bring it up a level and just end on the note of how can you get hands-on and actually try out this technology. It's very simple. Go to developer.ibm.com/blockchain. You can go there, spin up a blockchain network in a few clicks. Just this week and into next week, you're going to see our starter plan out there on our website so that you can go for free for 30 days. Try it out. If you want to increase and add more organizations to your network, you can move on to the enterprise plan. But basically, you can go and spin up a network, start experimenting. There's samples out there to help you understand the technology and help you understand how to actually build and grow a network. Read up on the documentations, on the documents. Dan talked about Hyperledger Fabric and Hyperledger Composer. Composer is an abstraction layer above Hyperledger Fabric that lets you build applications much faster. That's integrated here in the IBM Blockchain Starter Plan. So you can just very quickly spin it up, use the samples that are from the Composer site. And at the same time, last but not least, have fun. I do, like I said, believe that blockchain is real, it's here, it's now, and you can change your everyday life with this technology. So thank you.
All right, hi everybody. My name is Anjali Shenoy Dahiya. I am not the general counsel. I'm a senior associate general counsel here at AppNexus, and I work on our commercial and our privacy teams. And I'm going to be talking to you a little bit today about GDPR. I'm just going to give a very brief overview of what it is, and then I'm going to try and talk about the challenges it raises in the advertising industry. For us, and also how that relates to blockchain. All right, so what is the GDPR? It is this pesky four-letter acronym that strikes fear into the heart of pretty much everybody in the industry. But really what it is it's a law that is intended to bring transparency and control for users, for individuals at the end of that advertising transaction who are actually seeing the ad, to give them transparency and control over their data. And I just want to actually take a step back. It's not just for the online advertising industry. It's obviously across all industries, and it's affecting all industries in similar ways. The GDPR is going into effect on May 25th, but it's not brand new to Europe or to the industry. It's actually replacing what's called the Data Protection Directive, which is currently in force. The directive is basically a law, or not a law, but a direction to member states to implement laws in Europe. So basically what you have are a bunch of countries with all different laws trying to do the same thing, and there's no consistency. So the GDPR is one law across all of Europe that provides some consistency. Unfortunately, it's so vague that that consistency is really hard to understand. We're not going to talk about it too much, but there's also another directive called the e-privacy directive, and that is basically requiring consent in order to set or read a cookie on a user's browser. Okay, so I said it's applicable May 25th, 2018. It is actually adopted in May of 2016, and so we've had about 2 years to kind of bring ourselves into compliance, for all industries to bring themselves into compliance. It's about 70 days away, I think, and I know that because I live and breathe this every single day. All right, so I'm just going to go through some key terms very quickly. Just some things that we're going to talk about. So GDPR, it's about transparency for users with respect to their personal data. So personal data means data that's related to an identified or identifiable individual. And we're talking here about processing of that data. So when we say processing, we mean everything. We mean the collection of the data, the use of the data, the storage of the data, the transfer of the data. It's everything. All of that is the processing of the data. I'll talk a little bit about legal bases later. Some key ideas to understand: there are two kinds of ways you can be classified. You can either be a controller of the data. That means that you control and make decisions about how the data is processed. Or you can be a processor, which means that you just do whatever the controller tells you to do with the data, or in most cases, you can be both. Consumer rights we'll talk about a little bit later too. Security is just understanding what your obligations are with respect to keeping the data secure, so we don't have any like Equifax-like situations happening. Privacy by design is just thinking through how privacy plays into designing products and processes and features and functionality. And international transfers we won't talk about too much, but that's just the idea that when data transfers from Europe to a third country, there are certain things that have to be in place in order for that transfer to be legal under the law. Okay, so what does the GDPR cover? It covers, like I said, information related to an identified or identifiable natural person. Here in the US, we often call that PII. It's much broader than PII in Europe. It includes not just your name, your phone number, your email address. It also includes things like your mobile device ID, your cookie ID, your IP address, your lat long, anything that can identify a person, not necessarily all on its own, but if you connect it to some other kind of data, it can identify a person. Territorial scope. A lot of people are sitting here thinking, why does this apply to us? I'm in the US, I don't do any business in Europe really, I don't really talk to people in Europe, why does this apply to me? So yeah, it applies to companies in the EU and the EEA, but it also applies to companies if you offer goods or services in the EU, or, and this is important for online advertising, if you monitor the behavior of natural persons. So what does that mean? That means that you are putting those people in segments. You are serving them ads based on their interests. You're doing all the things that are necessary for online advertising to be useful for the advertisers and the publishers in the industry. And this means even if you don't realize you're doing it, if the person is sitting in the EU, or if they're located in the EU when you process their data or when you collect their data, you're being picked up under this law. Okay, GDPR. Does everyone need consent? That's the tricky word. Nobody wants to think about it. Like I said, there are legal bases for using the data. So if you want to go ahead and use data, personal data of a user, you need to have a reason for why you think you should have the right to use it. Consent and legitimate interest are the two legal bases that we think about the most in the online advertising industry. Consent means that it's informed, that it's specific, and that it's clear and affirmative, right? So I knew what I was doing when I gave this consent, and I gave it to you knowingly and affirmatively. I clicked on the page, I said, yeah, I agree to this, I'm gonna keep scrolling, whatever. Legitimate interest is a balancing test. It's saying, do the reasons that I want to use this data, do they override the fundamental rights of the user? Because if they do, or the individual, because if they do, I can't use the data under a legitimate interest balancing test. And you have to really think about what's reasonable for that user. What would they expect you to be using their data for? There are a few others. We won't get into them because I don't have that much time. Okay, so challenges. What are the challenges we're facing? So before I get into that, I just want to just show you these two slides. I'm not going to run through them, but these are basically just showing you the data flows in AdTech. This is on the sell side. You can see there's like a lot of arrows. They're going in different directions. All of those arrows, that's data flowing. This is on the buy side. And when I say data, Mike talked about the bid request, all of this data, all that personal data, IP addresses and cookie IDs and everything, it's on this data that's flowing. So you can kind of see there's all this data, it's very complex, it's moving back and forth. So what are the challenges we're facing? I'm not going to talk about all of these, but I'm just going to hit on a few of the big ones. So one of the things I just want to talk about, we talked about privacy in the context of business-to-business privacy, but GDPR is getting at users' privacies, individuals' privacy. And that's a really different topic. A lot of us don't think about that because we don't have the direct contact with that end individual. So we're not always thinking about what it means to be transparent with them. Transparency under the GDPR, it means that that user knows everyone in the chain who has access to their data and what purposes they want to use that data for. So when you think about that in the context of blockchain, right, you're thinking, how do you tell them, everybody, if you don't even necessarily know everybody in the chain that's going to get access to the data? How do you give the processes if you don't know how do you give the purposes if you don't know all the purposes that everybody in the data wants to use that, or everybody in the chain wants to use that data for? So these are things that we need to be thinking about. There might be a solution here, but we need to be very careful that we're not forgetting the individual's rights with respect to transparency. And then consent, right? We need to not just pass. So when we think about the transparency, we give the user transparency, and maybe the user has to consent or opt into you using their data. All of that data has to flow through the chain. We have to pass it along to every other company so that they know whether or not they can use the data for the reason that they want to use it. So how do you do that? How do you make sure that the data is flowing and that it's being kept secure while it goes through that flow? Those are things that we need to be thinking about. The other really big thing I want to talk about is data subject rights. So data subject rights are the rights that that individual user has with respect to their data once a company has it. So a company, they get this data in, they ingest it into their systems, they're using it, and then the data subject can come to them and say, I want to know what data you have. Tell me all the data that you have about me. Tell me every segment I'm in. Tell me my cookie ID that you have about me. I want to know what you know about me. So there's a couple problems here. One, how do you validate? How do you know that that user is who they are? I don't know your name. I don't know your email address. I can't connect it to anything necessarily. How do I know that you really are the person you say you are? We don't know. But when you also think about it from a blockchain perspective, every one of those companies has to be able to validate. They don't have any connection to that user, so they can't validate. The user also can say, okay, now we figured it out, got access to my data. I need to rectify it. You need to fix this line where you say that, this is my information, that's not right, you need to fix it. How do you make sure that it gets fixed all the way down the chain? That's very difficult. That's difficult even even outside of blockchain, that's a difficult thing to think about. So that's another challenge that we have just thinking about it now, but if you add blockchain into that, it becomes a little more complicated because the benefit of blockchain is that you don't that the ledger or the information you have stays the same for everybody throughout the chain, so it helps to alleviate things like fraud. But now you have to go in and delete it all down the chain, it causes another issue. They can also you can rectify it. They can also ask to delete it in certain circumstances, and they can ask you to stop using it. So all of these things have to flow. They can also withdraw consent. So now you have to tell everybody, no, we don't have consent anymore to use the data. If you were using it based on consent, you can't anymore. All of this has to flow through the chain, which is a very complicated problem, and I'm personally very excited to see what the solutions are. And one last thing that I really want to talk about is data minimization. So data minimization is the idea that you can only use data, the least amount of data that you need in order to do the processing that you want to do. So I get a certain amount of data in, I have to kind of cut out anything that I don't really need in order to do the work that I'm doing or the processing that I'm doing. So does the next company in the chain. So does the next company in the chain. But if I cut out some of the data, the next company in the chain doesn't get access to that data anymore. So it's just this idea of how do we think through these difficult topics when we're thinking about the idea of blockchain and the idea that data is supposed to be very secure and stay constant throughout the chain. So with that, I am going to hand it off to Aaron Brown. Oops, hold on, I have another slide that I just added. Aaron Brown, VP of Engineering at MadHive, who I think is going to address some of these concerns and has a lot of great ideas about it.
Hi, I'm Aaron Brown, VP of Engineering at MadHive. We love blockchain. We're a blockchain AdTech company based here in New York. Thank you very much to AppNexus for hosting this. So, blockchains. Blockchain is easy. I know that's kind of a hard sell after everything you heard, but we think blockchain is easy, and we're going to try to convince you that blockchain is easy. So, last summer at MadHive, we had a bit of an internal hackathon. And, usual hackathon rules, you get 1 beer per commit, and about 72 hours later, we had this. This was a complete, decentralized, blockchain, real-time ad server, which we were kind of proud of at the time. And since we're here at Tech Talk, let's dig into the tech. So ad serving on a blockchain is a little bit different. So I'm going to take a little blockchain liberty with the terminology, but really what happens is lots of information needs to get written to the ledger. That information is mediated by smart contracts. So when you're an advertiser and you want to put your campaign data into the ledger, you write that into a smart contract, and then say a consumer's device who wants to view ads, their device connects to the blockchain via a smart contract. Then there are matching servers, and these are sort of like DMPs, maybe a little SSP, DSP. Thank you for introducing all the terminology, save me. But it's a little bit all in one, but basically the matching server says, hey, okay, you're this person, I see this ad, you two need to go together. And so then the customer sees this ad, and that information is, again, written to the blockchain ledger, and all of these parties are sort of polling information. Everybody's sort of seeing the same thing, and so advertisers see the same things. Publishers see the same things. And then, of course, we have this new entity, the miner. The miner's job is to sort of take all the information that's being seen, group it up, put it on blocks onto the blockchain. And we actually have this live. Let me see if I can pull this up. Yeah. So as you saw from the slide, we built this on JP Morgan's Quorum backbone. And, you know, props to them, because I don't think anybody's tended this thing since last summer. It's still chugging away. So what you see down there in the bottom right, that's the consumer's ad. All of these 4 panes, they're next to each other just sort of like to see into it, but everything is live, open, and connected to the blockchain. Everything you're seeing is completely decentralized. So the ad view comes in, the IP, the user agent that goes on the blockchain, the matching server matches to an ad. See the advertiser view, this might be a little small. There's a bunch of hash codes and things like that. This is real time coming off the blockchain. And the publisher is accumulating money, ad views, they see what's happening. And then of course we have the miner. Down below this, if you go to the website, there's also stats, you sort of like real time view into the blockchain. So that was 3 days work. A lot of read the manual. It's not too bad, I promise. But what did we accomplish? So we saw everything. Anybody? Audience? That's your test, blockchain lesson. I'll help you. Transparency. Everything was there. So transparency is good. We like that. Causes some problems in business when everybody sees everybody else's business, but it stops fraud. And reconciliation is pretty easy because it's all there. Didn't happen on the blockchain. Didn't happen. It's not too bad when there's just a few nodes and a few small number of people. If you try to take that to hundreds of thousands or millions of ad views per second, it's not going to work. It's too slow. And then this other thing I wrote up here, still centralized. And that's a little funny because it sort of took us a little while to get our head around that. But one of the problems is, you saw in the data flow diagram, that everything was going in and out of smart contracts. And so sort of, even though we built this whole thing out of decentralized tech, it's all just smart contracts, and one entity controls all the entrances, all the exits. And so it is literally the centralized ad tech stack dropped on a blockchain, still centralized. So really, what we set out to do, we didn't really do. And so there was some sort of thinking about that, like, you know, what went wrong? Like, we did blockchain, like, we're there, you know, we made it. And we started thinking about this idea about, like, you know, like, what problem does blockchain really solve for us? And we think the answer is that blockchain is how you do collaboration. Blockchain solves the work of how you do collaborative work. And if you go back and look at this kind of thing, like, oh, okay, we had a lot of parties reading and writing from the blockchain, but they were just sort of working independently, doing the things that they do right now in the existing legacy ad tech stack. They didn't really get to any kind of collaborative work until that last final second. They collaboratively built a report. And so we saw some benefit. You know, we got the transparency, the reconciliation, but we weren't really using the tech to its full advantage. So we say, blockchain is not our destination. It's not where we're all trying to get to, because once we get there, it's kind of underwhelming. Blockchain is the origin. Blockchain is a foundational technology that we can start to do real collaborative work together. Collaborative work requires trust. You know, we can't really work together, and we do business, we use banks together. And trust has traditionally lived in application layer. You know, as developers, we use these protocols, which are, you know, The old protocols, you could say they're sort of decentralized. Nobody really owns HTTP, TCP, stuff like that. But everybody sort of talks the same standard. But the real trust is going to be in the application layer. And you see the biggest applications in AdTech ever built, Google, Facebook. Outside of AdTech, banks. These are huge, valuable companies. So it sort of shows you how much value is in trust. Now we go to the blockchain. The same thing is true. The protocol layer is the decentralized aspect, and the application layer is the centralized aspect. But the trust is now given to us at the protocol layer. And so what happens is we can sort of write these centralized applications on top of these great protocols and get the full advantage of trust without having to reach out to another party. So this brings up an important question. Is my blockchain project a distributed application, or is it a protocol? Before, when we were doing our hackathon, we just said, oh, it's blockchain. There's a bit more nuance to it. Really what we made was a dApp. And so dApps, we have smart contracts. The smart contracts are usually written by one entity. And another thing that sort of happened is we were putting all this ad data right on the ledger. And so application data was sort of limited by the throughput of the blockchain. And everyone at AdTech knows that's sort of a big problem. Protocols. Protocols are sort of like our agreement that we're going to work together. So we're starting with blockchain, and we're kind of building on that. And blockchain, while it's a collaborative work thing, there's also some like pre-work to be done. There's off-chain collaboration. There's lots of authors. We had to be mutually interested in sort of doing this thing together. We had to make a standard. We're going to do peer review. We're going to make requests for comments, white papers, and not the ones that you can buy online. They're like $50, like real white papers. Yellow papers to sort of prove out that everything that we're suggesting is mathematically sound. Protocols often support lots of distributed applications. And really important to our industry is now that you've decoupled application data and protocol data, if you keep the protocol to the layer that's writing into the blockchain, your application data is unbounded. So, things we can do with our new protocol. Privacy, not something you see in AdTech too often. But privacy can be cool. And from an engineering standpoint, we'll go into how that could work. Lots of people here, I hope, are familiar with the legacy stack. We have this idea about a protocol stack, and it makes our engineering life a lot easier because at each level, like the IP and the TCP, these guarantee like delivery of data. TLS guarantees security. Each level makes a guarantee up to the higher levels, and so I don't have to worry when I get up to the app and HTTP level. That's like my REST and OpenRTB data. I don't have to worry about these problems anymore. They're guaranteed from the stack below. A kind of similar thing happens in the blockchain stack. So in our POC, we had dApps sort of running directly on the blockchain. And we had problems. And we could have been served very well if we had a very specific ad protocol in between, sort of mediating those requests and making guarantees anchored in the blockchain and sort of providing guarantees in turn up to our dApps. So privacy is kind of a hard problem, but it's a cool engineering problem. And the way to start thinking about privacy is limiting the distance that data travels. So we've seen those big, long AdTech pipelines where data just flies all over the place. Already bad enough, nobody can keep count of anything. Then the government comes in and says, oh, well, you had a problem keeping count of impressions, now you gotta keep count of a lot more stuff, or you're gonna go out of business. So these are problems. So let's start with, from the ground up, let's keep data in one place. And since we're doing privacy, let's keep it with the consumer. And the consumer is the only person that has their data. This is kind of hard, but it opens a lot of really cool possibilities. So the way we do this is we introduce the concept of an agent. The agent is sort of your digital counterpart. It literally lives in your device, all of your devices. it is cryptographically sealed. So any data that you put in your agent stays there. It never leaves. Some very smart people did some very smart math, and they made sure that works. And what the agent is responsible for is sort of this communication layer between the privacy by design ad protocol and applications running above it. So, for example, like in this kind of advertising ecosystem, what advertisers do is they create machine learning models. And that's a little scary for some, but don't underestimate AdTech. There's a lot of really smarts in there. We do a lot of really good machine learning now. And so there is kind of a natural transition here to move from targeting ads traditionally to say, hey, I just have this model of what my customer looks like. You know, if you check these boxes, I want you to see my ad. And so advertisers create these models, and they're released into the protocol level. Now, when your application wants to show an ad, you don't make an ad request out to an exchange or to, say, like an SSP. You make an ad request to your own device. That's where the agent resides. And the agent says, okay, cool, you know, has maybe models in or goes and gets some models, executes these models totally inside the agent, and then once it finds an appropriate advertisement, that ad is then returned up to the DApp. All of these sort of stages are sort of very carefully orchestrated, but the engineering is made a lot simpler by layering the stack like this. Each layer makes guarantees to the next. So the blockchain gives us a base layer of security. You know, hey, if these bits go here, everyone saw it, and you can build smart security protocols on top of that. Then higher up, you can sort of do things that can handle the exchange of machine learning models. That way, stuff gets to where it needs to be, but nobody can really exploit that to figure out, you know, who is really seeing this or what private information resides in that agent. And then, of course, the agent can then do that, serve the ad up to the DApp. So, what can privacy do for my business? This is kind of important. You know, we're here, blockchain. Blockchain's fun. We love blockchain, but sometimes people want to make money. Well, we heard a lot of important things about sort of privacy. Privacy is good, but there's other problems. You know, like if GDPR is a problem for us and privacy is a fundamental human right, you know, are we at odds with our own consumers? Like that's probably not good and definitely not sustainable. But there are more problems in the AdTech pipeline. Everybody's sort of, you know, trying to game. There's fraud, there's accounting problems, big companies are bullies. Lots of things sort of need to be reset to make this industry work for us. So when you have a privacy by design system, advertisers get better targeting. That's because inside the agent, if the consumer can trust the agent to really hold their data, then advertisers have the opportunity to target on that, and they can get really good targeting. Publishers. So now all of this targeting has been removed from this long data pipeline, and it all happens at the edge. And so all of these ad requests are evaluated objectively. So publishers can get the real value for their inventory. Consumers, this is kind of cool. So not only do you get privacy, but if you are free to tell your agent anything that you want to, you can be really candid with your agent. Like it's not going anywhere. And so now you're almost like participating in the advertising experience. It's sort of a novel concept. I've never seen it out in the wild, but I'm ready for it. Like I want to sort of control what I'm seeing, and I want to see what I want to see. Brand safety. This is really big. Advertisers in the current ecosystem are really kind of helpless. You know, they sort of, hey, I have this banner ad or video, please get it somewhere. There's no control. Here, when you have these machine learning models, that at every single step of the way, we've done all the work to ensure that absolute privacy is maintained, the advertiser has total control over how their ad is shown, where it's shown, the manner, what places. And so they can preserve that. Fraud. One of the cool sort of side effects here is that when your device is running the agent, we can make guarantees using these neat cryptographic tricks that that device is only running one agent. And so now, if you want to run like MethBot or any kind of like other fraud or some kind of future fraud, you don't just get to fire a PC, load 1 million copies of this thing, and get firing off ads. You've got to fill a warehouse full of iPhones and Samsung TVs, and you get 1 agent per device. And that makes fraud really expensive, hopefully too expensive. And then, of course, since your data is not moving anymore, you get regulatory compliance for free. So we're really excited about our new blockchain future. Lots of other companies are excited about it. And this is just a part of the list of the companies that are helping to make this our new AdTech future. And so we, at MadHive at least, and I think many other companies, when we talk about is the blockchain ready for AdTech, we think the blockchain is ready. We're waiting for AdTech. Thank you.